Hey folks, welcome back. So in this video I will be explaining about the EC2 and EC2 instance and the security group implementation using Terraform modules. And before you continue this video, I have already submitted the entire code in my GitHub repository. I have linked my GitHub repository URL in the description. Make sure you check it out. Okay, so before I proceed, I would like to explain the architecture of this implementation. So as you can see on the screen, this is based on the previous VPC 3-tier implementation, and in this infra, I will be implementing 2 security groups and 3 instances, and both the resources, the security group and the EC2 instance, will be based on with their respective Terraform modules. So I'll be using the security group Terraform module and then the EC2 Terraform module. Okay. So let me show you the before I show you the code, I would like to show you the documentation, like how it is drafted. So this is the documentation page of the Terraform with respect to the security group. And as you can see, there are multiple examples already based upon the security group modules, such as a complete, computed, disabled, dynamic, rules only, and HTTP, and so on. In most cases, we will be referring to the complete example, and the complete example looks something like this. That too, if you go to the complete and main.tf, they have implemented the entire code base, the entire complete implementation of security group. And yeah, so as you can see over here, it has all the important arguments for the security group, such as the name, the VPC ID, the ingress CIDR blocks, and then the ingress rules, and then this, and then the egress rules. So based upon this example, I have implemented in my code. And in this particular code example, in this particular module, I have until F4 it is the same VPC 3-tier architecture. From F501 to F504, it's going to be the security group module. And then the F6 is going to be the data source from which the EC2 instance AMI will be referred, and from F701 to F704 it's going to be the EC2 implementation using the EC2 module. And then the F8 I have implemented a separate elastic IP resource, so that I can explain the depends on Terraform meta argument. And then the last one is going to be about the null resource and the provisioners. What is a null resource, and why is a null resource implemented, what are provisioners, and so on. And in provisioners I will be explaining the file provisioner and then remote exec provisioners. Okay, let's get into it. And I'm getting into the first security group module. So as you can see the architecture, so we'll be implementing the first security group with respect to the public subnets. And in the public subnet, the rules are such that only we can SSH into this public subnet, and it can come from anywhere. The destination can be from anywhere. So the CIDR block is going to be 0.0.0.0, and then since it is SSH, it's going to be port 22. So these are the basic rules required for the Bastion host security group. And if you look at the code base, we have mentioned the name, which is the Bastion host security group, and then for the VPC ID, we will be implementing the we'll be calling the module, which is a module.vpc_id. Okay, and then for the ingress block, which is this right over here, the destination and the port for which it will be SSH into, and we have the CIDR block, and then the SSH, the ingress rules, the incoming rules, that is the SSH rule. And for outgoing rules, which is egress, it's going to be all and all. So all the traffic can go out of this particular public subnet. So this is the module wise implementation of the Bastion host security group. And let's come to the private security group. It's almost the same, just that if you can look at the architecture, it's okay. So as I was saying, in the private security group, which is implemented through the module, If you look at the architecture, it's we can SSH, so there are two ports available for this, the SSH port and the HTTP port. The reason HTTP port is defined is because in the private EC2 instances we will be installing a small HTTP web server, and then we will be also implementing a small message, which I am going to show you in the shell script. Okay, and the destination from where and all it can accept the traffic, from which destination it can accept the traffic, it's going to be through the entire VPC. So within the entire VPC, the traffic can be accepted into this particular private subnet. So these are the two main rules which is to be implemented, and these two remains the same, the name and the VPC ID. And when it comes to the CIDR block, the CIDR block is the IP destination source, which is going to be the entire VPC module. So it's going to be module.vpc.vpc underscore CIDR block. And coming to the ingress rules, it's going to be the SSH rule and then the HTTP rule, which we have already defined, and the egress rule, which is all the traffic can go out of this particular private subnet. So this is the private subnet group implementations. And we also define the output variables, such as for the Bastion host, what are the output variables? It might be the security group ID, the security group VPC ID, and then the security group names. And then similarly is going to be for the private subnets. Okay, so now let's go to the data source. The reason we have used the AWS AMI data source is to get the latest AMI instance, the AMI of the instance ID, so that we can reference it into the creation of EC2 instances. So even this documentation is available in the Terraform. Make sure you check it out. And we have mentioned the owners as the Amazon, and the most recent is true. And this particular AMI is taken from the Amazon console, and the one of the filters is going to be the EBS, and the virtualization type is going to be the HVM. If you'd like to have any other filters like the operating system and so on, you can include that as well. Okay, so let's come back to the EC2 module. Okay, so this is the EC2 Bastion host or jump server instance which we have implemented. And yeah, so this is the one instance which we are going to implement using the EC2 module, and even this is based on the EC2 Terraform module. And as in the example, they have only two examples as of now, which is complete and volume attached. So let's check the complete example. EC2 complete, yes, and this is in the main.tf file. Please open that file and you'll be able to see this documentation over here. And in this particular EC2 module has all the arguments required for the EC2 service, such as the name, the AMI for the EC2 instance, the instance type, the subnets, security groups, and so on. So based on this particular documentation, I have implemented the code. And the code starts something like this. First we will be implementing the EC2 module, and then we believe and then we'll be giving the name for the EC2 instance, and then the AMI. For this particular AMI, we'll be referencing it from the data source file right over here. And then the instance type. So the instance type is going to be referenced from the variables right over here. So this is the instance type. Instance type is going to be t2.micro. Right over here. And then again for the instance key pair, it's going to be from the Terraform key, and that is defined in the variable section. Okay, and the subnet ID, and this particular subnet ID will be called from the module itself. And since there are two different public subnets, we will be indexing the first one, the first subnet ID, which is 0. And the security groups, it's going to be the Bastion host security group, which we have defined over here. So this particular security group will be referenced into the Bastion host. So this is the implementation of EC2 Bastion host Terraform script using the Terraform module. So now let's go to the private EC2 instances implementation using the Terraform module. Until here, it's going to be the same as the Bastion host. This is where the tricky part is. I tried certain permutation combination, it did not work because previously in the previous version we had another field known as subnet underscore IDs. In the IDs field, we could have directly mentioned the subnet IDs to where this particular is a private EC2 instance can be deployed. But since there is only one field, this is only field which can accept only one value, and we want to define the EC2 private EC2 instance across two different private subnets across two different availability zones. What I have done is that I have used an inbuilt Terraform function known as the element function. What the element function does is that it accepts a list, and in the list it will also accept the index of that list, and of that particular index will be passed on to this particular subnet, and for each different values of that list the resource will be created. It's as simple. And for this particular thing, and in order to support this element function, I have created the for each, and in the for each it's going to be indexing the index position such as subnet 0 and subnet 1, and subnet 0 and subnet 1 is going to be of both the private subnets, and that is implemented. And after that we also referenced the security group of the private subnets right over here. So I have referenced this using the previous security group module. So that I have referenced into the private subnets, and after that I have also referenced the app-on-install.sh. Let me show you what app-on-install.sh actually is. So this is basically a shell script which installs a web HTTPD server, and then it's going to display the message welcome to Akshay's YouTube channel, which is app1. So it's a very simple shell script, and that particular shell script will be referenced into the private EC2 instance, and the web server will be installed with that particular message, and that is with respect to the EC2 instances. So we have implemented, so right until now we have implemented the public security group, the private security group using the security group modules, and after that we have implemented the EC2 instance module for both the Bastion host and both the private EC2 instances across the both private subnets. So we are halfway done, and now let's go to the Elastic IP. The reason I have implemented Elastic IP as a separate resource is because I'm going to explain what depends on works. Okay, so first so with this particular resource a separate Elastic IP will be created, and then it will be attached to the EC2 instances, as you can see over here. So I have referenced it to the EC2 instance, and there is another meta argument for Terraform known as depends on. Basically what depends on does is that it will wait until all the defined resources are created, only then this resource will be created. It's like an if condition. If these resources are created, then this resource would be created, else it won't. So that is the purpose of depends on. Okay, so in the depends on, what I have done is that I have mentioned the first make sure that the VPC is implemented, and then the Bastion host EC2 is implemented. Once those two are in place, then go ahead and create the Elastic IP, and once the Elastic IP is created, associate that instance into the Bastion host EC2 instance. So this is the basic funda of the Elastic IP with respect to this thing depends on meta argument. And now let's go to the one of the hot topics, which is the null resource. So what is a null resource? Basically, null resource in Terraform is used to make changes to an existing resource in the cloud. For example, if you want to make any changes, if you want to push any file, if you would like to run any commands, if you would like to change the content of that particular cloud instance while it is getting provisioned, I think so the best case would be to use a null resource. how do you exactly use a null resource? In this particular case, I have two cases where I need to push the Terraform file from the okay, so this is a Terraform file, the key file which I have in my computer to the Bastion host EC2 instance. So this is, so that is one, that is case number one. And once the file is pushed onto the EC2 instance, we need to make sure that the file has certain permissions for it to be executed, and for that we'll be using the sudo command. And how this is exactly done? So first, in the null resource, we'll be using something known as a connection block. What the connection block does is that it is going to connect the computer, the local laptop, onto the EC2 instance, onto the cloud resource. So once the connection is made, we'll be using something known as a file provisioner. What file provisioner does is that it's going to take the file from the local computer, and it's going to be it is going to be pushed onto that particular resource which we have defined over here, such as the Bastion host EC2 instance. And once the file is pushed, we will be giving the permission, which is chmod 400, so that this particular file has the executable permissions from the EC2 instance. So these are the, so this is the overall code wise implementation of this particular architecture. So this is the entire code base, and once we have the entire code base ready, we will be going through the Terraform implementation, like Terraform init, Terraform validate, Terraform plan, and then the Terraform apply command. So once the entire Terraform commands are executed, we will have the AWS instances already deployed. So first we'll check the VPC instance, VPC resources, and then the EC2 resources, which we have already defined. So in the VPC, we already have the VPC demo 1, and then we have the subnets, both the public and the public, private, and the DB subnets across both the availability zones. And then we already have the assigned route tables, the public, private, and the database private route tables, then the internet gateways, and then the NAT gateways. So all of them are defined. Now we will go with the EC2 instances. Okay, so we have two private instances and across two availability zones. Let me show you the availability zones. Yeah, East 1A and East 1A and East 1B. So across both the availability zones, the private instances are deployed and one Bastion host is deployed. And if we check the Bastion host implementation, this needs to be assigned with the Bastion host security group, and the private instances needs to be assigned with the private security group, as we have deployed in the code. So it needs to be referencing the Bastion host security group, and then the private instance needs to refer the private security group, which is exactly implemented like we have explained in the code. So the resources are in place. So what next? Since we have implemented the concept of the provisioners, we have already pushed the local key file into the temp directory of the EC2 of the Bastion host EC2 instance. Let's check that. Okay, so we have all the so we have the private key folder. So let's SSH into the Bastion host EC2 instance. SSH-I private key Terraform key, and then the username is going to be EC2-user @ because we have defined the user as EC2 user, and then let's get the elastic IP. So it's going to be this, and paste. And we're going to type yes. Done. So now we are already in the Bastion host EC2 instance. Now let's check if we have that private key file in the temporary in the temp directory. ls tmp. Okay, so we already have the file right over here, the PEM file. So now let's SSH into the private EC2 instance. Okay, so now right now we have already SSH into the Bastion host. With the Bastion host, let's try SSH into the private one of the private EC2 instances with this particular key file, ssh-i tmp terraform-key EC2 user @ now let's get one of the private IPs of one of the private EC instances. So we got it. Let's paste, and then voila. So now from the Bastion host public EC2 instance, we have SSH into the private EC2 instance. From the public EC2 we have SSH into the private EC2 using and this was possible due to the null resource and the provisioners. So this was the overall implementation of the EC2 instance architecture setup using the Terraform modules. So in the later on videos, I would be explaining about the classic load balancers, application load balancers, and then the DB and then the VPC to DB implementation. So let's get started.